That's all right. Okay, so we are renaming fractions. Go ahead and take a moment if you're watching this to update your table of contents with your correct page number. All right. Are we ready to go?
Yes. I was born ready.
So, go ahead and stop talking because I'll just have to pause this and I will have to put some check marks down. Okay? Please stop. All right. So when we are renaming fractions, what we want to focus on is this word equivalent. I feel like I am spelling that wrong. Let me EQU. I am. Let me try it a third time. EQUIVAL, equivalent fraction.
Miss Span, I can't see from here.
I'll do something about it.
Okay.
All right. So we're looking for equivalent fractions, and I want you to listen to that word equivalent, and what is the word that you hear inside of there, like a root word?
Wow.
Equal. So we hear equivalent or equal fraction, okay? And this looks super messy, but I'm going to go ahead and put my dash here, and I am going to write my definition underneath, and that is a fraction. These are fractions with equal value. Now, yesterday, when we were looking at comparing fractions, we said, okay, you know what? Let's take a look at our fractions and compare them to how close they are to being half of what their denominator says, right? Half of the denominator. And so we were able to look at them, and if they had a 10 in the denominator, that tells us how many make a whole, right? We were like, okay, well, half of that would be out of 5, right? Half of that would be 5 out of the 10. So we were able to look at it and say, okay, I can name what half of that fraction is. What we're going to do today is take a fraction and we're going to make it into another fraction entirely, but they have the same value. All right, so hold on to that thought for a minute and make sure that you have this definition down, as messy as it might be. And I'm going to switch this over for a second. Okay, is everybody good here?
Yes.
All right. What time is it? It's right there on the board. So I'm going to start with, this may not work. All right. I'm going to start with the fraction 3/4. All right. Let me put this as my first example. So I'm going to go ahead and I'm going to make a visual here. So numerator is 3, denominator is 4. Remember, that's my part over the whole. I have 3 pieces out of 4 that make it complete. So I'm going to draw and make sure that I have 4. We're going to pretend that those are nice and even. Okay? And they will never be because it's me. So if I am going to shade or show what that 3/4 looks like, I would color in 1, 2, 3 out of the 4.
3.
It's 3/4. Don't be a smart mouth. Now, if I want to change this fraction into a completely different fraction, but it has to be equal in value to 3 out of 4. There are a few things that I can do. Now, as I am looking at this, one thing that I noticed right away that I could do just to my visual. Well, does anybody want to guess? What can I do to this right away just to change it but keep it an equal value? Zach?
Fill in another box.
I could, okay, but that would make it one whole, right? I want to keep it at 3/4. That's a good guess, though.
Write it differently?
I'm going to take it and I'm going to just chop it in half like this. Now, instead of 4 pieces, I have
6.
8, right? I have 8 pieces. So, let's take a look. Now, if I have 1, 2, 3, 4, 5, 6, 7, 8 pieces, let's name the fraction that is now shaded. So, out of 8, right, my denominator is going to change because if I did color in all the pieces, I would color in 8 pieces. Are you with me? All right. How many are shaded?
6.
Violet?
6.
6 is correct. So now I have named it 6 8. Does it, just by looking at the visual, can you see that these fractions have the same value? They have the same worth, right? They cover the same amount, only we have changed the denominator. So, if I can say that 3/4 is equal to 6/8. Agreed?
Yes. Yeah.
Okay, so let me see if I can get into this.
It's because
Now-
it's double what the other thing
It-
Jiggy would.
Okay, and I love that. So what he just said was, it's doubled.
I'm so
So
smart.
this is actually a little ahead of the game, but let's go ahead and go there. Okay. What I did mathematically with this visual. Is everybody okay? Can I keep going?
Yeah.
Remember to say if you need a second.
Wait, I need a second.
Let me know when you're done. So when I cut it in half, Zach said I doubled the fraction.
I'm so smartest fan.
So think mathematically now. If I'm not going to draw a picture of 3/4, 3/4, how would I, if I just started right here, how would I double 3/4? Hold that. Let me see if somebody else picks up what we're throwing out. How can I double
They don't.
3/4? Okay, I see one more hand. Think about it. Think about it.
Like how I double it?
How would we double this?
I
How would we double it? Okay. Anybody else? Weston, how would you double it?
Couldn't you add like the 4 plus 4 and the 3 plus 3 and like just add it together?
Maybe. You could do that. I mean, you could just say, or you could say 3/4 plus 3/4, right?
Therefore, this is it off.
But what's something else I can do that's even faster? Remember, we want to streamline and work smarter, not harder, with our math. That's why we love us some shortcuts. Colton,
Put a line through it.
through the 3/4.
No, like I see how you did it.
No, I'm not using a visual. I'm looking at 3/4. I'm looking right here. This is it. This is everything. What can I do to double this? Carson.
You like take the 3/4 and then you add like 3/4 onto it. Like,
Okay.
Like 3 plus 3.
Yeah, so you could add 3/4 and 3/4, but like I said, there's another way to do that where we can kind of streamline it and work smarter, not harder. Zach, what would you do?
What I would do, respectfully.
And quickly is.
Oh.
Mm-hmm.
So I would mess around with the thingamajiggy until I get something that equals the thingamajiggy.
Okay.
The thing with you.
Or
I don't know.
what if I did this?
Oh. Well, you're smart, so.
Now, I could just, if I want to double it, I could just multiply it by 2. Now, here's where you got to understand something. If you're going to create an equivalent fraction, what I do to the top, I do to the bottom. What I do to the bottom, I do to the top. You cannot make a change on one and not the other. It has to be done on top and on bottom. It doesn't matter how many times I multiply this fraction or by what I multiply this fraction. It's going to be the same value. will hopefully have time before the end of the school year to take fractions and turn them into decimals. And what you will find with 3/4 or 6/8 is that they are equal to 75%. Okay? So they have to be changed on top and on bottom. So right here, I want you to write change top and bottom. Of course, our real math talk would be change numerator and denominator. Now, I'm going to go ahead while you're doing that, and when he comes back. And she. I'm going to go ahead and multiply both, which of course gives us our 6/8. What I do to the top, I do to the bottom. We will be saying that over and over and over.
Miss Stan,
Yeah.
can you do it with double digits? Like, can you do 6 times 2, 8 times 2? Like that? And be like 12.
Oh yeah, you could keep going forever. Yes. Carson's saying, could we make a third equivalent fraction by multiplying the 6 and the 8 by 2? And yes, you certainly can. As long as you're multiplying them by the same amount. By the same amount, by the same
Can
amount.
you do it like all the way up to like 1,000?
Sure. I don't know why you'd want to, but you could if you needed to. Yeah. Okay, hold your eyelashes out and then literally just look down and hold it until it's super uncomfortable. Just look down, look down, look down.
It is super.
It's going to feel very dry and ick, but it will fall out eventually.
Well,
Now
preppy
blink, blink,
girl
blink, blink.
crisis.
Try it again if it's still there.
Is that a preppy girl crisis?
All right. All right, so here's example 2. So if I have
Can't really
the
see.
fraction 1/2, let me fix that for you. Thank you. All right, so if I have 1/2, again, I can create a visual, right? Pretty quickly.
Because I'm smart.
And I can shade it in
You're so
to show, Zach, thank you, but I don't need any more comments from you, sir. All right, now I've got 1/2 here. So again, if I need to create an equivalent fraction or an equal fraction for 1/2, one of the easiest things I can do, letter 3 please, is take that visual and I'm just going to slice it in 2. Everybody with me?
Yes.
Now, could I slice it this way and this way also? I sure could. I mean, I can dice it up as many times as I want, but the fastest and most simple way, and by the way, with math, simple is good. Less is more. All right? Don't get all fancy. Big numbers. He did.
Can I go?
Sure. So let's create a fraction now for what is shaded. Somebody tell me what I would call that fraction. McKinley.
Are you serious right now?
I am dead serious because you never stop talking or making noise. So I'm not calling on you. I love you.
I love you.
2/4. Now this is going to look the same. Again, what did I do when I look at 2/4 compared to 1/2? Now I know visually I split that sucker in half in 2s. What did I do to it? Mathematically, if I'm just looking at 1/2 and I need an equivalent fraction to 1/2,
Times 2 it.
I just multiplied it. What I do to the top, I do to the bottom, and that gives me 2 times 1 is 2, 2 times 2 is 4. So y'all, 1/2 is equal to 2/4. Okay? I'm going to go ahead and put a square on that. I'm going to come up here and put a square on this one too real quick. All right? So 1/2 is equal to or an equivalent fraction of 2/4. Yeah, Carson. When Eli comes back, Colton's going. When Colton's coming back, you can go. All right. Nope, that's enough. So, let me take a look, see here. Now,
You're probably thinking of Davis.
And that's going to be a check mark. We don't talk about people, and I quote, taking a deuce. Thanks.
Yes, ma'am.
Glad I just said that on this recording. All right. So, are we good? Are we good? Now, we can also take and create equivalent fractions by reducing them. All right. So, for instance, if I have, I'm just trying to understand their visual here, and I don't really like it. Okay, so let's do this as example 3. So if I have 2 8s, I'm going to go ahead and make a visual here. And we're going to, again, pretend that that's equal. All right, so I've got 8 pieces here, and I'm going to go ahead and highlight 2 of them.
Wait, can you go up a little bit? Just like that.
There we go.
How to get that.
Okay.
Oh. Okay, I'm good.
Now, looking at this visual, I want you to think opposite. Now, before we sliced it in half, Audrey and McKinley. Y'all with me?
Yeah.
You will never sit together again. Okay, so think opposite now. In the past, we sliced it in half. Slicing and dicing. So what? Look at that visual and try to think relationships as far as what do you notice about groups, about groupings. What do you notice about how it's set up? How can we create an equivalent fraction or an equal fraction to 2 8s here using this visual for a fraction that is smaller? Audrey, I'm pretty sure I'm calling you. So you keep on whispering to your friends and we'll wait for you. All right, so I want you to just take a look at it and think about the pieces that you see here. Think opposite of cutting. Right? So we want to look at it as a bigger picture. See what is already there that we wouldn't have to change. Okay? And just and take a look at what that might look like. How? Miss Lewis said you already knew. All right, so take a look at it. Audrey, what do you think? What do you think here? Let's just focus on the 2 8s. Imagine it before being cut. How about that? So, like I said before, we would have taken it, and to make the equivalent fraction, we would have cut it in half. So picture it as though it might have been before we sliced and diced it. What would it have been before then?
Well, it could have been like.
She's got this. Y'all put your arms down. Calm down.
Pause. I literally. I just had it.
Cap.
No more comments, Mr. Broussard. Thank you. Where would you have sliced it down the middle like we did the other two? Looking at that visual, where would you? Right down the middle. So if I didn't, wait, you mean like down the middle like this?
Yeah.
Okay. Either way, we're going with it, right? Okay, so if I had not sliced it right down the middle there, name that fraction for me. Imagine that line is no longer there. What do you have now? One, what?
Are you serious?
Not a whole. One out of what? How many pieces would be there?
2.
Grace, help her out.
Oh,
1 out of 4. Now listen. Imagine this line is not there. Then I would have, I'm going to go ahead and just draw it to make sure you can see it. There are my 4 slices. If I don't have the line, And then I still just have one of them shaded. So that becomes the 1/4. Now, if I am looking at 2/8, thinking, okay, I want an equivalent fraction for 2/8, but I want it to be smaller and a simpler fraction. I want it to be an easier fraction. What did I do here to this when I move this visual over? Because they take up the same, they have the same value, right? They take up the same amount of space. They are worth the same. They cover the same amount of territory. I mean, we could say this 1,000 different ways. So what did I do mathematically to go from this to this? Keep in mind, we want to make a connection. When we added the line to our other examples, we had more pieces. It got bigger, right? And we did what? Holy guacamole, y'all. Look up here. When I went from 1/2 to 2/4, I added a line and my fraction got bigger. Yes, my numbers got bigger. I got more pieces. I had 2, now I have 4. How did I accomplish that mathematically? Josh,
Just right.
you better answer me. Don't ask to go to the bathroom. What did I do? You what? You better answer this because I'm pointing at it, and if you don't, I'm giving up my career and I'm gonna be a greeter at Walmart. I'll see you there. Come on. What did I do when I made it bigger? Mathematically, I did what?
You fried the chicken.
Oh my gosh.
Oh my goodness.
Lord help me. Weston, help me, Weston. What? Listen, Linda.
You multiply.
I multiplied. So when I multiplied, listen. So look, when I multiplied, it equaled bigger. I am getting smaller. So think about math. Think about relationships. Where's my multiplication cousin? Right? Where do I connect to multiplication? Colton.
Minus.
Not quite. Now that does make it smaller. But think of adding and subtracting are connected, Grace. Divide. When I divide, listen. When I divide, it gets smaller. I'm going to take something and I break it into pieces, right? So what I did is I took these 8 pieces and I divided by what?
2.
Think about it. What did I have? With this bar, I had 1. And let me do this. I had 1, 2, didn't I? And now I just have 1. So think about that. Think about those 2 groupings and those 2 sections. For a 2 to become a 1, what do I do to the 2? I divide it by
1.
2 divided by 1 equals 2, y'all. 2 divided by what gives me 1?
Oh!
I'm calling Weston again. 2 divided by what, Weston?
2.
I divided by 2. And when I divide, remember what I do to the top, I do to the bottom. 8 divided by 2 gives me 4. Y'all, 2/8 is equal to 1/4. So if I want to make my fraction smaller, if I want to make it simplified, I looked here for a number that will go into the top and the bottom. Here's your binder, babe. And I divided both. What I do to the top, I do to the bottom. Are you with me? Okay. Now, I'm going to go ahead and stop here with this, and we will continue probably after lunch. All right? Hey, stop. So